our next speaker. So Renée is a professor at the Department of Geography from McGill University, and she looks into the use and value of information technology by communities. And she'll be talking to us today about crowdsourcing winter storms, and quite excited to hear about this. So over to you, Renée.
Did someone call for us for a social scientist? Okay, so here I am. Marion, can you see the screen?
We can see it well.
Excellent. So I'm Renée Sieber. I'm at McGill University in Montreal, Canada, and I'm reporting on a project that I'm doing for Environment and Climate Change Canada. So hi, Claude and Brian. Also shout out to Sarah. Hi everyone. Before I start, I just want to situate our project in citizen science. So this is from my colleague Mookie Hackley at University College London, and he arranges citizen science in 4 levels. So the sorts of things that I am doing and where we engage social media is at level 1, which is called crowdsourcing, and looks at citizens as sensors of the environment. And why is that important? First of all, it's important because citizens can be engaged at various levels of deliberative action. And it's also important because citizens acting as sensors of the environment is incredibly valuable for the environment and also for extreme weather events. So citizens can act as sensors because they are closer to the phenomena, they live or work in the area under consideration. There are more of them than credentialed scientists or crisis managers, so there's just sheer numbers. If, as the previous presenters pointed out, if we can get them to continue to contribute. They can sense change because they've been in these areas for a long time, presumably. They are able to investigate, to go outside, to write social media posts, to take photographs. And there's been a lot of research done on the accuracy of citizen science contributions, and Mookie Hackley and others have reported that citizen science contributions can be as accurate or more accurate than credentialed officials. So there's a lot of research that we can draw on to look at this accuracy question. Citizens can be sensors of snowstorms through social media contributions on Twitter or Facebook or Instagram as examples. These contributions can be extremely useful because crisis managers can find out what's out there in terms of impacts. The contributions can provide situational awareness, and hopefully citizens can distribute important information to other citizens. The thing is that once you get to a certain volume and velocity, these contributions have all the advantages and disadvantages of big data. Now, you might be able to read 100 tweets, but can you read and absorb and create meaning out of 100,000 tweets? Social media data, as probably all people listening right now know, that it can be very redundant. It can be filled with a lot of noise. In other words, not terribly useful information. A lot of this content has little semantic structure. It might just be a cluster of words and not necessarily be set up as sentences, for example. We use natural language processing. It's a part of artificial intelligence to hopefully transform these contributions into actionable content for crisis managers. and hopefully make us a little bit more resilient in the face of some of these extreme weather events. So our project is looking at different kinds of classification models for contributions about extreme weather events. So really what we're doing is we're playing in the sandbox of data science and computer science, or applied computer science, to look at how we can get actionable information. So we have performed for floods and also for snowstorms 4 or 5 different kinds of classification models. We first performed a supervised classification, and I'll talk about what that means in a minute. We augmented that with social networking analysis. Well, it was sort of good and sort of bad, and I'll talk about the trade-offs at the end. We also conducted an unsupervised classification. We found pros and cons for use in crisis management, but also as it's applied in the citizen science realm. So what is this thing called supervised classification? For those of you who've done any remote sensing, you're well aware of supervised classification. What it does for us here is it organizes citizen contributed content into predetermined categories. And I'll show you a slide with these categories. It can categorize in near real time, which is, very useful if you're dealing with a real-time extreme weather event. And it tends to be more interpretable and actionable because you've already determined what the topics are and you've defined them, and you're slotting in this content, the new content, into these categories. Before it's used, supervised classification requires very large training data sets, which also come from citizens, but these training data sets have to be annotated by hand. It's typical, supervised classification. The classic example is distinguishing images of cats and dogs. You need to have a huge data set in which humans actually said, this is a cat and this is a dog. And then you can put new unlabeled data into the supervised classification. Sometimes this human annotation is done by citizen scientists. Often it's not. It's done on these crowdsourced platforms like Amazon Turk or Crowdflower. The reason that we started with supervised classification is that it tends to be the gold standard for crisis managers. There is a very large training data set out there called Crisis Nlp that has been used for a number of years now. It has been used across many different kinds of extreme events. It's supposed to be universal across these extreme weather events, which we found maybe not so much, but we'll talk about that in a bit. So where are we? First of all, here are the categories in Crisis Nlp, and you can see why people might think these would be quite universal. From casualties in a crisis to infrastructure and utilities damage, and these you would normally think, these will be really good in situational awareness, but a lot of reports of crises also are in these more emotive categories, like I'm offering my services, I want to give a donation, and I want to lend emotional support, thoughts and prayers. So that comprises a great deal of the contributions from citizens about extreme weather events. There also is a large category of not related or irrelevant tweets, that hence the noise in social media data. Here's how our snowstorms stacked up. you can see the hashtags that we use to filter to create our initial corpus of tweets. I think we had, I don't have it here, around 30,000 tweets that we were working with. This is a logarithmic scale, by the way. You can see that a lot of the tweets do occur in these more emotive categories. One of the challenges for us was that a lot of tweets ended up in other useful information, which compelled us to go and actually do random sampling to find out what was going on in this category. But it was very fast and for situational awareness, pretty good. Just to give you a sense of the tweets that were captured in this automated process, under casualties, an 83-year-old man is dead in the wake of a collision involving a snowmobile and a pickup truck. Yes, you can see the automation did its job, the NLP did its job. In terms of donation needs, offers, and volunteering, the irrepressible account name has been organizing shoveling crews for the past few days, and they've been helping, they've helped countless people. And you can see, yes, the irrelevant information is quite irrelevant, although it was notable how many images in the Newfoundland and Labrador snowstorm actually was people snowboarding off of snow-covered cars. So yes, there was a lot of that. I'll just give you a sense of the challenges for supervised classification. Is here are some examples of other relevant. I'm guessing that the multiple flashes of light from transformers blowing means we won't give getting power back anytime soon. Roads are snow covered with slippery sections, but good visibility, freeze and rain beginning now. Now is quite helpful that they included the hashtag, but the Crisis Nlp and supervised classification isn't as universal as we might like, because snow is not a 50-year or 100-year flood event. It occurs quite regularly in Canada, and we might want to create other categories to encompass what happens when there are these extreme snowstorms. Also, snow, unlike some other events, is comprised of quite distinct sub-events like freezing rain, and it can be somewhat difficult to capture the high winds, the freezing rains, as part of a snowstorm. So that's what causes us to think about perhaps going to unsupervised classification. I take a little pause here to say that we also looked at social network analysis, because Environment Canada wanted to know not only what people were contributing, but who they were listening to. So in phase 1 of our project, which actually was on US data in the state of Nebraska on a flood, we looked at what people, who people were listening to. And we did use the US state, because one of the challenges of doing these classification models is you need a lot of data. And Canada, as Claude already brought up, is a very thin slice, and you don't always get enough data. So at least when we wanted to test our system, we wanted to test it with a robust corpus. To your right, you actually see the snowstorm data and its visual representation in a cloud. It can be very pretty to look at. It's a traditional graph structure of nodes, which are the accounts, and edges which connect to other nodes. It can show you how text spreads across multiple social media users, but it can be extraordinarily hard to interpret. So it may take a fair amount of teasing out to make some sense from this pretty image. Whoops. So we did that, and thankfully we found that it is official sources that people are listening to, that Ricketts is Governor Ricketts, the governor of Nebraska, and you see the Nebraska State Patrol and Nebraska National Guard. So we can be confirmed of where people are getting their information, although as we've discussed with my colleagues at Environment Canada, the public doesn't necessarily know where they're getting their weather information from, and that can be a real problem when weather bureaus spend enormous amounts of time in being accurate and the public is getting it off of, you know, sensationalized weather reporting service. Let's move on to unsupervised classification. We use topic modeling here. It categorizes a corpus of citizen contributions when the labels aren't known, when you actually want the labels to emerge organically and bottom up. So what you get is clusters of words or word pieces. These can be interpreted and labeled, and you'll see in a moment why it can be challenging, obvious or not obvious, what label should be applied. The preparation is far less labor intensive because no prior training of data of the model is required. However, you have to assemble a corpus first, so you have to get a large number of tweets in this instance first, which can be kind of problematic if you want near real-time or real-time situational awareness. So here are the clusters for our Newfoundland and Labrador storm of this past year. And I've highlighted topic 4 because it corresponds to the category in the supervised classification. And we're looking at, as part of our research, how we can create hybrid models of supervised and unsupervised classification to take the best of both of them. But when you look at some of the other topics, how do you label bread, song, coffee, and favorite and girl? And likewise, the most prevalent topics and the least prevalent topics you might have to throw out because you can embed a lot of the noise in this unsupervised classification. One of the nice things about working with unsupervised classification is there are a lot of software libraries out there, so you can visualize the topic distribution. It should be noted that these topics are not mutually exclusive, and a word or a word piece occurs, can be in multiple topics. It's the percentage of times that it clusters with vectors of other words, for example. But you can see the topic 1 is fairly distinct from the other topics. So in conclusion, there are 2 general conclusions for citizen science and for crisis managers. So obviously, citizen contributions offer an important new source of information. There are issues, however, when relying on citizens as sensors. There's incredible temporal skew in the reporting, unsurprisingly. There's a burst of activity, and there's a very, very long tail of multiple kinds of contributions. Obviously, there are demographic biases. There are people who have the luxury of reporting, who have access to robust data plans, and they can report. And people who may be most severely impacted, well, cell phone access has gone down. There are platform access issues. The reason that we talk about Twitter so much is because a lot of these other platforms have cut off access to us, and Twitter might not be far behind. So if we're going to rely on these platforms, maybe we might need to have these custom built apps where people are reporting directly. There are privacy concerns. You have to be really cautious because if you're reporting this out, you could easily violate the privacy of individuals. And I would also add, for citizen science, you need respect. You need to respect the citizen scientist, the contributor. Let's say you ask people to use a hashtag, but then you don't acknowledge them, or you don't allow others to follow you. You don't create a two-way platform on your with your Twitter account. Sometimes a two-way street is important. The implications for crisis managers. Well, some of these methods are better or easier to use than others. Some of the methods are closer to real time than others. Not all of these approaches are transferable, even though there is this sense that they should be universal across extreme events. We did find some challenges in taking data that had been trained on floods and earthquakes in Pakistan to snowstorms in Canada. And they're not always easily interpretable. So you saw the challenges in looking at labeling the topics in unsupervised classification. They're definitely not automatic. And despite the fact that everyone's talking about classification methods and AI and NLP, if you don't have a data scientist on your team, you're going to find it quite difficult to do that. So with that important caveat, thank you so much. And if you have any questions.